Showtime. All right, good afternoon. I am on audio, right? Test, yeah. So my name is Jay Krepke. I'm product manager for SUSE Linux for HPC, among other things. Talk a little bit about high performance computing. But before I get into that, I want to give you just kind of a little kind of history of where SUSE has been in high performance computing. As you'll see in some subsequent slides, SUSE has actually been quite active in high performance computing over quite a few years. And in fact, we have somewhere around 50% of the top 100 high performance computing installations that are out there are running SUSE Linux. The challenge is most people don't know it. Most of the people that do it kind of know it, but most people outside don't really understand that SUSE has had a long history in high performance computing and one that we're actually expanding at this point. So part of our job is not only to improve our product, but also to improve our perception of the product so that the customers understand what we're doing here. I took over HPC at the beginning of 2017. And at that time, we were just starting to roll out some new stuff that my predecessor, Kai Gupka, had initiated around high-performance computing. But since I've had it, I've done quite a few other things there. Let's kind of talk overall about high-performance computing and what we've been seeing. Number one, high-performance computing is a growth industry. Things that were formerly kind of kept purely to large-scale modeling and simulation projects have percolated down considerably, not only into other aspects of, say, the aerospace industry, but also just generally across many different industries. So finance in particular is one where you've seen a lot of investment in high-performance computing because it's a way for people to get an edge, to get an advantage over their competitors. And so we've seen that, it is a growth industry. There's a lot of reasons for people to invest in it because they get good payback. But it is changing, and it's changing fairly dramatically over the past 5 years or so. Part of it is growing into to a different set of businesses other than just, let's say, seismic and aerospace and things like that. But also the workloads that are run within high performance computing today are changing themselves and how those workloads are used. So we've seen pretty significant change overall, but the bottom line is it is a big industry and it is growing. Now, if we look at some of the things that are driving changes in the industry, AI and ML integration is certainly one of them. You heard at the keynote today, we talked a bit about, Dr. T talked a bit about AI and machine learning. This is really being a kind of a transformative technology, and it's not one special technology that lives on a hill. It's something that is really being embraced by a lot of different businesses and institutions. And along with that machine learning and AI is use of heterogeneous technologies. And so, 10 years ago, you would run on one set of processors and that'd be it. So maybe you'd be running on an IBM Power processor or an Intel processor or what have you, but it was pretty much homogeneous kind of environments. Now we've seen the tremendous rise in what we call heterogeneous HPC. That means that you have workloads that are running on combinations of CPUs, but also GPUs and even FPGAs. So it's an industry that's changing. And the reason that they're doing that is because the workloads in the past where you used to just do modeling, and then at the end of the modeling or a simulation, you'd come out and you'd have your answer. Well, now they're actually using machine learning and AI as a way to either figure out what they want to go look at specifically, or also to validate what they got out the back end of the modeling and simulation. So it's a way to refine their answers. A good example of that would be in the area of, say, medicine or drugs. You can put information into a AI or machine learning and get an idea for a compound that would have a positive effect in a drug environment, but you can't just take that and go to market with it because the regulatory agencies need to know how you got to that answer, right? And in a machine learning type environment with neural networks, you have an answer and you have a confidence that it is the right answer, but you don't know how you got there. And so you still need to use, in that case, simulation and modeling to figure out how they got to that particular answer. So it's a way to weed down the possibilities so that you can focus your effort on things that you know are going to have a positive impact. So that's been extremely important. Somewhat related to that is the use of container technology. So let's turn the clock back about 5 or 10 years, and an HPC environment would be set up with a number of different sets of libraries, and people would run their applications, run their workloads on it, and then over time, those libraries would change. In fact, they're very dynamic. You see a lot of changes in the HPC libraries. And so the problem was, if you were a user and you had used a particular version of the last library, you wanted to recreate your findings, you had to find a way to get to those old libraries. And so there was a lot of effort that had been done over the years to make sure that there were ways for the end user to use the specific set of libraries that they started out with. Well, that's really, there's a lot of pain in that. That requires a lot of intervention from the system administrators. It requires a lot of knowledge on the path of or on the point of the users themselves. And so they were really looking for an easier way to get reproducibility. And container technology provides that reproducibility. Because with a container environment, you can basically encapsulate all the libraries that are needed for a particular workload into a container, and you can just dump it on the system and run it. And it doesn't matter what the system libraries are, because they're actually using the stuff that's inside the container, which means that 10 years from now, if you need to reproduce that experiment, you can take that same container, put it on whatever the current technology is of that day, and get hopefully the exact same results, because you're using all of the dependent libraries when you try to reproduce it. So container technology you may be familiar with in sort of the DevOps environment for doing microservices and quick development. In the HPC environment, container technology is really being done around encapsulating the workload environment so that you can use it, you can reproduce it later, to make you independent of the kind of overriding system. And then we're seeing the introduction of new architectures. So there certainly have been HPC environments, if you go back far enough, run on IBM System Z on the mainframe many years ago. And then you started to see Unix kind of take over, and architectures like Power or Solaris or those kinds of technologies. Well, we have a new entrant, and it's ARM. And we'll talk a bit about what ARM has been doing around HPC. HPC offers kind of some unique advantages for a new architecture, because so much of the HPC environments are done by people who really know what they're doing. So they don't have dependencies necessarily on a third-party application. They're basically using open source, and they're able to therefore kind of fit very easily into a new architecture. All right, I've been there. Okay, sorry, I wasn't in the right place. So when we look at an HPC environment, and you think of an HPC environment as typically may have 100 to several thousand nodes, there's a real challenge in that just managing that many systems. Even though they look very similar in most cases, it's still a management headache to be able to manage that many different nodes or installations. And so that leads to, when you start adding the software stack into it, a whole lot of complexity. In fact, I was at a HPC conference about a month ago where one of the maintainers of a package called MVPIC was showing the dependency chart for his particular library, and it had over 1,000 different libraries that were dependent on that it was dependent on or were dependent on it. And so, one single change in that could potentially affect the reproducibility. So makes for a very complex environment. So that's a challenge. The other is, how do you maintain an environment? We saw things like Meltdown Inspector a few years ago that really kind of highlighted to people that they needed to make sure that their environments were protected from malicious hacking and things like that. Now, a lot of HPC environments exist in kind of walled gardens where they don't really have a lot of exposure to the outside world, but there are certainly opportunities for exposures there. And so making sure that you maintain your system, that you know that once you put the system down, if there is a critical problem, you're able to protect yourself by putting on the patches you need to maintain it. And then all of these things really affect time to solution. So because we're seeing more businesses now use HPC-like technologies, they may not have a bunch of PhDs in the background that are used to managing HPC. So you've got to figure out, well, how can I get something just up and running quickly? They're not in business to do science or do something kind of esoteric. They're really trying to make a buck. And so they can't have, a lot of requirements to do a lot of hand tuning, a lot of hand work. They want to be able to get up and running as quickly as possible. So these are kind of the challenges that we've looked at in SUSE and our high performance computing is how do we deal with these particular issues? Now, we can't do HPC alone. We have a lot of partnerships in SUSE. In fact, we're expanding our list of partners. But if you look at some of these, and I'll talk about some of these in more detail, you see obviously the hardware vendors, the people that produce systems that are ultimately used in HPC environments are out there. You see software providers in here. Typically, where you see a lot of effort is in scheduling, because that's one of the areas where you can really do a lot of optimization. And then you see some kind of fundamental technologies like the processors themselves. So the Intels, NVIDIAs, etc., Marvell are producing technologies that are later consumed by the hardware vendors to provide the hardware solutions that HPC runs on top of. So SUSE's got good relationships with lots of partners, and in fact, as I said, we are expanding some of these. So let's talk about HPE here at the beginning. This list, no particular list, it just had order, it's how they got out here. But we've been working with HPE quite a bit over the past several years. We are a preferred partner for HPC in a number of different environments out there. And we've got a lot of technology that we work together with HPE to deliver to their customers. And I'll give you an example of that here coming up soon. We're not only just working on kind of the traditional platforms, the x86, whether it be Intel or AMD, but we're also now expanding into the ARM environment. And so we've got a partnership that we are working with HPE to produce some of the first ARM servers that are delivered for the ARM environment. That's called the HPE Apollo 70. It is built on the formerly Cavium, now Marvell Thunder X2 processor. And we've gone to market with HPE and ARM to try to build out this market a bit. One of the challenges when you introduce a new technology is that high-performance computing environments tend to have a considerable amount of tuning. So there's a lot of tuning that, in some cases, is really affected by the underlying hardware architecture. So one of the challenges is to get machines out there so people can really start using it for science, so they can start understanding where the architecture has strong points, where it has weak points. And so we're working on a project right now called the Catalyst UK that I'm going to tell you more about here in a couple of charts. And I'll also give you an idea of why people are looking at ARM as an option for HPC environments. But have no illusions. The large majority of everything that's out there in HPC today is running on Intel processors. For the most part, ARM is at the very early stages of this. And so the Catalyst UK project is really intended to kind of move things forward. So as I mentioned, this is a partnership between HPE, ARM, and SUSE, and 3 leading UK universities. So University of Bristol, Leicester, and Edinburgh are all installations that have received a cluster of 64 Apollo 70 servers. So each one of these universities already has extensive experience in high-performance computing. What they are doing is saying, okay, let's take these ARM systems, put them into operation, and see where we need to adjust the underlying open source software, make it work better, things they might need to adjust in some of their algorithms to take advantage of some of the platform advantages of ARM, and also really just kind of shake out the software stack. ARM has been around for a long time, but ARM server platform is a relatively new thing. We've only been supporting ARM now for since 2016, which is just 3 years ago. Prior to that, there was no commercial support available. We were the first and continue to be one of the, certainly the most extensive support for ARM today. So, excuse me, and so all of these experiments, these 3 sites, are running on SUSE Linux Enterprise for high performance computing, which is now a specific product tailored for high-performance computing workloads. We'll talk much more about that. All right, so where are we with Catalyst UK? So these 3 64 nodes complexes were shipped out from the US at the end of last year, so right around the end of supercomputing in November. They started prepping those machines to ship out. HPE preloaded SUSE Linux Enterprise FUT1142 on each one of their systems, and they also installed their HPE High Performance Computing Cluster Management, HPCM, on those systems. So other things that we're doing, and you'll see later on that SUSE actually provides a number of very useful common HPC packages, one of which is a workload scheduler called Slurm. So we provide that as part of SUSE Linux for HPC. At this phase, the systems have been deployed. We're going through initial qualification and testing. They're finding some kind of interesting edge conditions in some of the libraries they use, making some adjustments, and kind of getting ready to move forward to actually do some science on them. Once again, the purpose of these machines is not really focused exclusively on doing new science, but it's on kind of filling out the overall HPC software stack. And these 3 universities, despite the fact they're all UK universities, have very different workloads, and they also have very different approaches to HPC management. So it's a real kind of a good test for the overall, the overall market is to have these 3 universities there. Now, this is a picture, or at least a depiction of an HPE Module 70 that's out there with the Marvell ThunderX 2 processors on them. That's out running today with SLES 12. We have at least one customer that is looking forward to moving forward with SLES 15, and they'll be doing that probably in the next 2 or 3 months. We also have provided to these customers SUSE Enterprise Storage. So SUSE Enterprise Storage, and I screwed that up there, it says server, it should say storage, is our Ceph-based software-defined storage. We're providing that as part of this project. I'll talk more about how SUSE Enterprise Storage can fit into an existing HPC environment today. So one of the things you'll start to see is a little bit more noise, a little bit more results coming out of the Catalyst UK project. We are planning a Birds of a Feather session and perhaps some other sessions at ISC in June in Frankfurt. So if you're at ISC, hope to see you there and learn more about what we've discovered so far. Now you might say to yourself, well, if just about everything in the world is running on Intel, why are you doing ARM? And so there's a lot of reasons for that. Some of the reasons are because we want to try out different things. We want to find better ways to approach this problem. And so one of our other partners in this is Cray. So Cray runs an environment that they call CLE, Cray Linux Environment, which is actually based on SUSE Linux. And so that's where a good chunk of our market share comes from, is that we have people that are running CLE that is based on SUSE Linux. It's just not branded externally, it's branded as Cray. Now, Cray also had a project around the Marvell ThunderX 2 processor that they wanted to get early views to see, was it commercially viable? Was it something that they really wanted to go out there? And of course, Cray is extremely well known as a big share of the top 500 sites. So about 2 years ago, Cray instituted this initiative that they're running on a system called Isambard. And Isambard was a kind of an interesting gentleman in UK history, but they created a prototype service, or a prototype system, the XC50 system, which has now been announced and available, as a way to start getting information on what would they could actually do with ARM versus Intel. And so this is an example of a chart that's a couple of years old now. But one of the things you'll notice is the ThunderX 2, in some workloads, has considerably better performance than top-tier Skylake or Broadwell. So there are certainly cases where the ARM architecture on the ThunderX 2, because it has more memory channels, is able to more efficiently do tasks that apply to memory. And so in this particular example, the T-Leaf 2D, you can see it's well above anything that you can get from an Intel Skylake. However, there are other workloads, like this Snap workload, that is not memory intensive, it's more compute intensive, and and therefore the ARM processors, the ThunderX2 processor, is not nearly as performant as the Skylake, and it's barely better than the Broadwell. And you might say, well, okay, that my workload looks like that. Maybe I'll just not look at ARM. Well, there's another factor involved here, and that's the cost of the chips. Okay, so Marvell has been very aggressive about pricing their ThunderX2 processors. So in some cases, it may make more sense for an institution to use ARM chips that are lower performant, but they can get more of them. So there are a lot of reasons why people may choose ARM versus an x86 environment. Kind of inherently the way that ARM works, and you guys may not be aware of it, but the ARM Limited Company, which is now part of SoftBank, they don't make chips. They make designs for chips. And so they license that IP to vendors who then produce the chips. And there's two kinds of vendors. One type of vendor will just take the design that ARM creates and just instantiate it in silicon. So they'll go to some third-party silicon vendor, they'll have the chips made, and boom, you're out the door. And using the ARM architecture and the ARM designs. Another type of chip designer, chip company, has an architectural license. And these are people like, for example, Marvell. So not only can they take the designs from ARM, but they can modify them as long as they stay within the ARM architectural limits. And so this gives them a lot of flexibility to add things like additional memory channels or additional I/O channels. Really, they can define the chip to meet the workload. This is one of the big advantages that ARM has compared to the legacy chips that are out there today. And it's also the source of one of the biggest headaches that we have, is that there is so much diversity. If you look at power, for example, there's one vendor, IBM. If you look at x86, there's really a couple of vendors. It's Intel and AMD. If you look at ARM, there are dozens and dozens and dozens of vendors. And out of that dozens of vendors, there are quite a few that are architectural licensees that have a lot of flexibility to do things. So for us, it makes our job a little bit tougher, because instead of just dealing with one partner, we may have to deal with 1 or 10 or 20, depending on what we're trying to do there. So it's both a blessing and a curse to some example. But to the end user, the idea is that I can get a chip that is exactly focused on what I need to do. And for high performance computing today, the only chipset that's really doing it for high performance computing is the ThunderX2. But there are definitely others on the way. There will be other chips you'll see in the next year that will be applicable to a high performance computing environment. All right, speaking of our friends at Intel, Intel doesn't just sit there, they're moving along too. They've been adding more cores, and doing a lot of things to aggressively get more performance out of their chips. And in fact, one of the things that you'll see if you deal with HPC is that a lot of times people do multiple sets of benchmarks. They'll do one benchmark with GCC and then do another benchmark with the Intel compilers, okay, which have been optimized for the architecture. And sometimes those optimizations can provide quite a bit of additional performance. So that's something that Intel's been investing in for decades. They obviously know that architecture well. And while ARM has its own set of compilers that are focused on getting the most out of their processors, they haven't had nearly as long a track history. So there are multiple people playing in the game. The benefit, of course, for the customers is anytime you have competition like this, prices tend to go down, price and performance goes up. We also worked with Lenovo. Lenovo is one of the ODMs that produce systems that are used in AI environments or in high-performance computing. Lenovo actually has their own HPC stack. They call it LICO. And they do that to provide a management and control stack. And part of that stack is actually using things that we provide as part of our SUSE offerings. I'll talk more a little bit about that in a moment, but LICO is kind of their special sauce for doing HPC environments. And Lenovo is doing stuff just beyond the kind of the old style HPC. They are doing a lot of investment in AI and machine learning. In the past year, they've really expanded their offerings in that space. Now, we had a pretty good win with Lenovo a couple of years ago. This was the LRZ Computing Center. This was a center that the original bid was to use CentOS, use free Linux on it. And when they found out the things that SUSE provided in addition to our operating system, they said, gee, we're going to switch from CentOS, an unsupported CentOS, and move over to using SUSE Linux. So this is a geophysics type of application in here. There are about 6,000 nodes now, I believe. So that's a pretty substantial HPC environment today. SCEDMD I include as one of our partners here. SCEDMD is a software provider that are effectively the maintainers for the SLER workload manager. So there are a number of different workload managers available for HPC environments. We'll talk about several of them, but Slurm is really probably the most predominant one. And while Slurm is completely open source and available to anybody, SCEDMD does provide support for that. Now, SUSE also provides support for Slurm, but we only provide kind of the break-fix type support. So just like many things in the Linux operating system, if there's a problem detected, we will work with the community, which in this case includes SCEDMD, to find the fix and to deliver it for it. We do not, however, do consulting around Slurm, and that's one of the areas that SCEDMD does do. And in fact, they have offerings to do a three-day course for their customers so they understand how Slurm works. They work with the customer to do the configuration and the layout of it and put it into place. So this is an example where we have two open source companies, SUSE and SCEDMD, that are providing complementary services. We do overlap on kind of the break-fix area of it, but they provide a lot more capability on the consulting side than we are able to provide. NVIDIA. Okay, we talked a lot about machine learning and AI, and a lot of people seem to think that AI and ML is only done with GPUs. That's not true. You certainly can run machine learning type workloads on top of just regular CPUs. But NVIDIA can provide, with their GPUs, can provide a huge acceleration. These are accelerators, things that make workloads happen much, much faster. And if you've been paying attention to what NVIDIA has been doing recently, they've really been doubling down on their AI and ML. So they now provide things like groups of containers, pre-built containers that are enabled for GPU acceleration, that have things like TensorFlow and other AI type workloads. They make that available. Now we're partnering with NVIDIA. We consume their services. There are little challenges around NVIDIA and some of the other partners in this industry in that NVIDIA does not open source their drivers. They consider the drivers to be their proprietary, and so they don't make the source available for them, which means that we can't, as an open source operating system, include those drivers in our distribution. That would be a violation of the GPL. So one of the things that we're doing with NVIDIA right now is to make it easier for our customers to consume the NVIDIA drivers, the proprietary drivers that NVIDIA provides. Altair. Altair provides a group of products, but the one that's most well known is something called PBS Pro. PBS Pro is a workload scheduler, okay? Just like Slurm, it's a different approach to workload scheduling. And if you looked across the industry, you'd probably see that PBS has, 20% or so, maybe more, of the overall kind of scheduling workloads across HPC. So it is very commonly used, not only in academia, but actually more importantly in kind of business applications. Because not everybody wants to try to wrestle Slurm to the ground. They want some help. They want something a bit more polished. Now Altair provides an open source version of PBS. Okay, but their PBS Pro is kind of more focused on ease of use and things like that. So we're a partner for Altair, and particularly for commercial HPC environments, solutions like Altair's PBS Pro might be a better approach than something like Slurm, which requires a bit more expertise. Now another customer that's really worked to simplify high-performance computing management for a business environment is Bright Computing. So Bright Cluster Manager's been out for quite a few years now. Once again, they provide a system for managing compute clusters. It's designed for ease of use. So they're not planning on having a whole bunch of PhDs in the background to maintain their environments. So Bright Cluster Manager's another one of the competitors in the computing management space. And then finally, Univa is yet another environment that provides for a commercial HPC environment. And you can see that it's been used on a number of systems. How do you say that, Jeff?
Tsubami.
Tsubami. Thank you. He tells me and I never remember. So that's a large Japanese HPC cluster out there. And so, like I said, we partner with a number of different vendors. And even though they compete against each other, they all need an operating system underneath there. And so, we like to work with these guys as well. So let's talk about what do we provide. Now I mentioned earlier, we had this bid at LRZ that was focused, was initially targeted for the CentOS free Linux operating system. And so we do, of course, provide commercial support for Linux. That's what our core business is providing commercial support for Linux. And one of the things that we saw in the aftermath of Spectre and Meltdown is there were a lot of people that were running out there that said, this stuff worked really well, but now I'm a little concerned about the security. Are there things going on in my HPC cluster that maybe I don't know about? Maybe somebody's put a Bitcoin miner or something in there. And so by having a commercially supported operating system, we were able to mitigate things like Spectre and Meltdown, as well as all the other CVEs that come up all the time. So that's really one of our core values. And that's essentially what we did with HPC for SUSE for a number of years. But as I mentioned earlier, a few years ago we decided to change a bit. And instead of just providing a low-cost operating system, Linux operating system, we started to add some HPC software to add in. And one of the challenges with HPC software is that it does change a lot, okay? It's rapidly evolving all the time. And, when we put something into the SUSE OS, into the base OS, we really only get kind of one chance to update it, and that's the next service pack, which is about every year. Well, we needed a faster mechanism to deliver software for HPC. And so we came up with this concept called a module, which we already use for things like our development module where we update our compilers. And so we created something called the HPC Module, and it's part of SUSE Linux for HPC, but it's just got a delivery mechanism that allows us to update it a bit faster. And so we include a number of popular software packages in there. I'll show them to you in a moment. Now, I understand that my primary competition for HPC workloads is free Linux. Okay, so it's hard to compete with free, but we attempt to do so. And in fact, we price our subscriptions for SUSE Linux for HPC extremely aggressively. It's a very large price discount compared to what you would pay for enterprise Linux. And the justification for that is, an environment like LRZ, which has 6,000 nodes, they don't have 6,000 different systems. They have one system 6,000 times, okay? And so we can afford to support those 6,000 systems for a much lower cost because we're not seeing 6,000 different variations. We're seeing basically one variation or a few variations across many thousands of nodes. So that's really the rationale for pricing subscriptions quite aggressively. And I already mentioned the fact that we have had a long track history in HPC. So if we look at the continuum of what we provide, obviously the product itself, SUSE Linux Enterprise for HPC, which is available both on x86 64 and the ARM AArch64 platforms. Both those platforms are fully supported and they're virtually identical. There are a few little platform-specific things that are different, but overall we provide the same level of quality, same code, the same packages for both of those architectures. And the HPC module itself, as I mentioned, is part of that. It's just packaged separately so that we can update it more often. And a lot of the content in the HPC module is kind of inspired by OpenHPC. So if you're not familiar with OpenHPC, OpenHPC is a project we started a number of years ago, and SUSE was one of the founding members of. And the idea was there were lots of different HPC packages out there, lots of different ways of building it, doing QA on it, and installing it. And so what Open HPC was really an attempt to say, let's take all of those packages and try to get standardization so that a customer that wants to set up a new HPC environment will be able to go to Open HPC, get the packages, and know that, number one, they've gone through the same kind of testing and build phase, but also that they have similar installation processes. And so we are a member of Open HPC, and there are hundreds and hundreds of packages in Open HPC, more than we currently support or probably ever will support. But it is certainly part of our involvement in the HPC environment. And often we look at things like Slurm that are available in Open HPC. We say that is popular enough, we want to make it available as part of the SUSE HPC module. Now, there are things that we cannot support because it's just not well used enough, or maybe it's because it's evolving quickly. And so we have another way to deliver software packages to our customers that are community supported, and that's through something called Package Hub. I'll talk about this more later, but basically it's a way for us to make available to our customers HPC packages that they can install just like they were a package that came from a SUSE distribution, but they're not supported by SUSE, they're supported by the community. Now, like I said, I'll talk more about that in a moment. Now, we do have a free community-supported OS distribution called OpenSUSE. And within that, there's two kind of sub-distributions. One's called Leap, and that is very, very close to SUSE Linux Enterprise Server. It's basically the same structure, a lot of the same builds. In fact, everything that goes into SUSE Linux actually has come through SUSE Leap, OpenSUSE Leap at one point. So that is a free community-supported operating system. So if customers decide they want to go it on their own and not get any support from anybody, OpenSUSE Leap is certainly a valid choice, and it gives them the opportunity, if later on they want to move up to SUSE Linux Enterprise, we've now made it very, very easy to move from OpenSUSE Leap 15 to SUSE Linux Enterprise 15. Since we are developing, as I mentioned, new platforms, the ARM platform, we do make available developer subscriptions. We've done that for x86 for a long time. We now make that available for ARM as well. So if somebody wants to experiment or maybe port their applications from x86 over to ARM, they can get a free developer subscription. It gives you a full year of patches, and in fact, we're looking on ways to extend that. Now, a lot of what I've been talking about right now has kind of been focused on on-prem. But that's not where we stop. We actually do have customers that are running HPC workloads inside clouds. And you can't do that with all workloads, but if you have workloads that are not extremely data heavy, like say seismic analysis, if they're compute intensive, why not take advantage of some of the cloud offerings that are out there? So we both work with both Microsoft Azure and AWS Cloud to make available our HPC images out there. And we have customers that are using all cloud, but it's actually quite a bit more common to see people that are using hybrid approaches. I have one German customer, for example, that's in the automotive space. They do CFD and other computational intensive type workloads. They have about 100 node server farm. For them, that's about as much as is affordable. If they need to go beyond that, then they burst up to either AWS or Azure. So it kind of depends on where they can get the best spot rates and where they actually would run and do it. So, we see that fairly often. There are certainly customers that are doing HPC exclusively in the cloud. I just don't deal with those guys that often. But it is certainly an emerging and expanding space there. There are some related products around HPC in addition to the operating system. I'll talk about more later. SUSE Enterprise Storage and SUSE Manager. So we do have some other irons in the fire, but certainly SUSE Linux Enterprise for high performance computing is kind of the hallmark for us. Now, we did split out as part of the renewed focus on HPC. Last year we split out HPC as a separate product. So prior to this, our HPC offering was actually just part of SLES. So it was basically, to be honest, a cheaper SLES, okay? But it was essentially the same license subscription, it was the same everything, except for the price. Well, we said we want to do some things around HPC that may be different than the generic general purpose SLES. So we split off, starting with SLE 15, we split off the product into its own separate product. So it has its own subscription keys, its own SCC channels for updates, and all of that. And this gives us the ability to do some more tailored stuff with the operating system. So for example, in SLE 15, we now have installation roles specifically for head nodes, compute nodes, and development nodes. So if somebody's setting up an HPC environment, they can select those roles and get an appropriate set of packages installed on those particular systems. So once again, it's a way we're trying to make it easier for people to set up new environments and manage new environments. Now that did have some implications. So customers that had purchased the old SLE HPC were actually using SLES keys. If they need to renew or if they want to move up to SLES 15, they're going to need to change their keys. And there's actually a little process that you have to go through to change. There's a little thing, a little text file inside SLES that says I'm SLES or I'm SLE HPC. There's a little script you have to run in order to switch that, and that's documented here. By the way, of course, all of these, this presentation will be available. It's already been sent to them to made available after the conference. Okay. So let's talk a little bit more about our HPC offerings. So I already mentioned that we're available for x86 and ARM. We've added some additional things though inside of just the base operating system. So one of the challenges with HPC environments is there's generally a strong desire for stability. And in fact, many HPC environments typically were deployed and never updated after they were deployed. And so customers are interested in having a really long service life. So we've created some new offerings to provide that for our customers. One of them is called Extended Service Pack Overlap Support, also known as SPOS, and don't blame me, I didn't name it, I inherited the name. And the other is Long-Term Service Pack Support. So I'll show you examples of that, but we've had these things around. For example, SPOS has been a part of our SAP HANA offering, but we've now extended that to HPC as well. And same for LTSS. Now, when you get down to the dirt of how do you order things, some people that sell software for HPC split up their pricing based on whether it's a head node or a compute node. SUSE doesn't do that. We have one single price for every environment, for every node in the cluster. So we don't care if you have 20 head nodes or 50 head nodes and 1,000 compute nodes. We don't care. You add up the number of nodes, and we charge one price for each one of those nodes out there. So it's a lot easier, particularly if you're, if you're a seller and you're working with a customer that doesn't quite know what their distribution of head nodes and compute nodes is going to be. This makes it really easy. Count up the nodes. We got one price for all of it. As I said before, we have really aggressive prices. I repriced our HPC offerings about a year ago now. And for example, I lowered the price on standard support for HPC by 40%. So it was already pretty discounted. I lowered it by 40% on standard and 55% on the priority support. And we do have a lot of business customers that purchase priority support because these things are starting to become business critical to their environments. We also added support for smaller cluster sizes. So we have some partners, particularly that are trying to help small business customers start to use high-performance computing techniques for their businesses, but maybe want to start out small. We used to have a 60 node was the minimum cluster size. Now we're down to 4 nodes. And so, if you want to start out small and grow up from there, we're not going to penalize you and charge you a lot more for those initial 4 nodes. If you do use the SUSE HPC product though, just be aware there are restrictions in our terms and conditions. So you can't buy SUSE HPC and then slap Oracle databases on it and run transaction services on it. That's not allowed, okay? Because remember the rationale for the discounted prices is you're running workloads across many, many similar services. I already mentioned the new product, SLE HPC 15, so let's move on. And by the way, notice that we call it SLE HPC, SUSE Linux Enterprise HPC, not SUSE Linux Enterprise Server HPC. So just a differentiation there, just to throw people off. Now let's talk more about the HPC module. So all the packages in the module are supported by SUSE. It's available for ARM and x86, and we try to update these several times a year. I would like to get to a quarterly update cycle, I don't quite have the engineers and QA to do that yet, but bottom line is we are able to respond faster. This is kind of the eye chart that shows the packages in our current HPC module. Just highlight a couple of them. Well, I'll highlight, for example, Slurm. So Slurm, the workload scheduler that I mentioned before, we originally deployed it at 16.05.8. That was in the beginning of 2017. We moved it up to 17.2.9, and now we're at 17.11. And the next update to it will be 18.05-3, I believe. So once again, these software packages tend to get updated fairly often, and so we provide new updates and new packages. Now you'll see a mixture of things out here. Some like Slurm, or workload manager or utilities. Some are things like like LiveBlaz, that are libraries. We've included some libraries in here, and we include MPI libraries and a number of different libraries. We're probably going to change our focus a little bit and focus more on utilities, because those tend to be really, really stable, or at least more stable. And to be honest, the complexity of managing all the different interactions between different versions of libraries is more than we can really do. So we're going to have to leave that to the customers to kind of match to their specific environment. But all of these packages, we've done a couple of different releases now. All the packages are available x86 and ARM. To install the package, it's really easy. If you don't select it at the initial install with SLES 15, you can add it later on, and this is just kind of the mechanics of how you do that. All right, I mentioned Package Hub earlier. There are, tens of thousands of software packages out there, not only for high performance computing, but for everything. And so we can't support all of those at SUSE, right? And so what we do, though, is that we do make available select packages that we think our customers want to use, but for various reasons we either don't want to support, they're not popular enough, or maybe they're evolving quickly. Specifically in the HPC space, there are a number of packages that are kind of highlighted here. One of the first ones we did was Cluster Shell. We had a customer that really wanted it. Didn't see widespread use, but we said, yeah, we'll put it in Package Hub. The reason why customers like things in Package Hub is they can just do the zipper install just like they were installing a regular SLES package. So it's exactly the same kind of look and feel as when they do the install. Robin Hoop is a similar one. You'll notice this next one down here called Singularity. Singularity is a container and a container runtime environment that was invented by a gentleman specifically for HPC environments. So it's in ways a competitor to the OCI/Docker type container. It is really focused on HPC environments, and it has some pretty significant advantages over Docker for these containerized workloads on HPC. That being said, in 2017, when I first started working with HPC, Singularity was barely a mention in ISC conference in 2017 in June. By the end of the year, we heard a lot more about it. Now, a couple of years later, it's all the rage. Lots and lots of people are running Singularity. So this thing has been evolving very, very quickly, so it really wasn't appropriate for us to support it initially. But this is one of those things that certainly I would look forward to in the future as being one of the packages that we'll be providing support for. Lots of demand for Singularity out in the container environments. If one thing is certain in HPC environments is these guys are inventive. By the way, the guy that invented Singularity also invented CentOS. So he's definitely got his chops. Definitely has his HPC environment. All right, let's talk about lifecycle. And this is a little bit of an eye chart here, but you can see the big blue bars are SLES 12 on the top and SLES 15 on the bottom. We're staying in sync with the normal SLES releases. And in general, we come out with a new service pack about every year. So in SLES 12, you see that we came out with Service Pack 3 in September of 2017. Service Pack 4 came out in fourth quarter of 2018, and we're expecting Service Pack 5 at the end of this year. And as you go through different releases, okay, when the successor Service Pack comes out, we provide a 6-month period where you can continue to get support on the previous service pack. And that's okay for kind of a commercial workload environment, But because HPC guys like to leave their systems stable for longer, we now have this optional offering that's called SPOS that gives them a full year of additional, a year and a half basically of additional support. And so a customer can purchase the SLES for HPC subscription with SPOS for only a 20% increase in price. So it's a relatively modest increase in price, gives the customer a much longer time to stay on that service pack before they have to move off. Now, if the customer can't move off even at that period, but still wants to remain supported, they can purchase LTSS, so up to 3 years of LTSS. One of the things that we specifically did around HPC is that we provide an LTSS offering that is specific to HPC, which says it's got the same significant discount as the base OS. Now we have other products that are related to HPC. SUSE Manager I'll start with first. Particularly in commercial environments, people like to know that they have a mechanism for patching all their nodes in a cluster. Now not all HPC systems do that, so it's not generally, it's not the widespread use there, but particularly for business type environments that want to make sure that every node in their cluster has all the latest patches on it, SUSE Manager is the solution for that. And we do that, make that available for x86 and ARM. The other one on there, the most significant one on there, is SUSE Enterprise Storage. And I'll talk more about that in a subsequent slide. Now, there are some environments out there that are using OpenStack as a scheduling mechanism or as a mechanism for their users to submit jobs for HPC environments. So we do have SUSE OpenStack Cloud. However, to be honest, I haven't had a customer yet that wants to use that combination. So if that takes off, we have that option. But for us, really, kind of the primary thing that we look at as a companion product for HPC is SUSE Enterprise Storage. So if you're not familiar with SUSE Enterprise Storage, this is our Ceph-based software-defined storage solution. And the idea is that you can buy boxes with compute and storage in them, and you pay per node price. So we don't charge you on how much storage is in each box, and you can just chain these together and you make really, really big environments. Now, Ceph today is not fast enough, for most cases, for the nearline HPC file systems. There are other file systems like Lustre or BGFS or even IBM Spectrum Scale that fill that role. But HPC environments, particularly the ones that are dealing with lots of data, tend to have a lot of data that needs to be archived. And so what we have customers using SUSE Enterprise Storage for today in HPC is primarily for archiving. And in fact, we've got customers that are using this today, and it's a growing list of customers. Now, SUSE Enterprise Storage is available both for the x86 and ARM platforms, and in fact, down in our solution technology showcase, all the way at the far end of the hall, there's a company called Embedded that is showing SUSE Enterprise Storage running on Marvell Armada ARM chips. So this is a mature product. We're currently working on SUSE Enterprise Storage 6. That will be based on SLES 15. But we've got a lot of customers out there already, and we've certainly got customers in the HPC space, primarily for archiving. All right, this is just kind of a chart here, just showing you what we believe to be the SUSE share out of paid Linux. Now, there's a lot of unpaid Linux out there, but if you look at the paid Linux in the top 500 list, this is how we kind of figure it out. And some of this we have to work at, to be honest, because not all of the systems in the top 500 say explicitly what OS they're running on. So Jeff did a lot of work back there. Jeff back there did a lot of work to kind of come up with this. But we figure that we've got well over half the market share of paid Linux in the top 500. So once again, this is not a new business for us. We have hundreds, thousands of customers out there using SUSE Linux or SUSE Linux variant CLE. All right, where are we going to go in the future? I kind of hinted at some of these things a moment ago. So one of the things we absolutely are working on right now is to make it easier for our customers to consume AI and ML frameworks. So that involves work on the framework themselves, making those available, but it probably even more importantly, requires us to do a job to make it easier for customers to consume third-party drivers that are proprietary. So the two main ones that we look at in particular, NVIDIA, the CUDA driver stack is proprietary, so we're going to make it easier for people to consume those. And similarly, the Mellanox InfiniBand driver set, also known as OFED, Mellanox OFED, is another proprietary stack that is well used in HPC. Now with the recent announcement that NVIDIA is acquiring Mellanox, those things just kind of come together naturally. So that's one area that we're working on quite a bit. We are continuing to build out our HPC module, so we're adding additional packages to it. As I said, we're probably going to focus more on packages for utilities, less on the libraries themselves, but we are continuing to build out there. And then we're also looking at, a little bit further down the line, is how do we do things to make our HPC, SLE HPC actually tailored for the operating system itself, tailored for HPC workloads. So for example, if you look at SUSE Linux today, it's a general purpose operating system, and so it's got specific configuration settings in it and tuning around running lots of virtual machines. Well, you don't typically do that in an HPC environment, so that's things that we're going to be able to deliver in subsequent releases of SLES 15, so they may not have that. So there'll be a bit of a divergence, still common code base, but different tuning choices, different configuration choices to make our SLE HPC much better for an HPC type workload. And that's it. So what you should have seen here, we got a pretty comprehensive range of operating system features around high performance computing. We price it simple, we price it competitively. We offer HPC packages specifically for our customers that we do support, in addition to the ones that we provide as community support. We give a number of options around lifecycle. If a customer needs a longer lifecycle, is willing to spend a little more, we can provide that option. If they're focused purely on cost, you can start out with a low cost and grow up from there. We do enable x86-64 and ARM-based systems, and as new generations of ARM processors that come out that are applicable to the HPC environment, we're going to take advantage of that, as well as add-ons like the accelerators, so the GPUs, the FPGAs, and other types of accelerators. And of course, we have Package Hub and OpenSUSE for software that is community supported, not supported directly by SUSE. That's it. So questions?
Maybe not, it's not related to your talk, but you mentioned support for FPGAs. Are there any universities or any real customers who have real demands for FPGAs?
Well, that's the challenge. We've seen some customers that have talked about FPGAs. In fact, one of our ARM SoC vendors has some options around FPGAs. In fact, ARM themselves have some plans for accelerators in there. So it's not something that I've seen yet in great detail. I know there is at least one university that was working with Xilinx ARM processors with FPGAs. So there's certainly some interest in there. FPGAs offer some advantages in the fact that they're programmable, so they offer a lot of flexibility. The downside is they consume a lot of energy compared to custom ASICs or GPUs. So there's trade-offs there. So it's going to be kind of dependent on a particular workload whether or not FPGAs fit in there. I'm not seeing widespread use for them at this point, but we expect that the AI and machine learning, we're barely at the beginning of this, right? So we want to provide our customers with all the options we can.
So the market share is pretty small, and even on top of that requirement is even smaller.
Yeah, it's pretty small at this point. But if think about 5 years ago, you would have gone to an environment, and with the exception of something like an Intel Xeon Phi, you didn't see accelerators at all. It was just processors, right? So this whole environment is changing, and AI and machine learning are really changing the underlying requirements. Thank you very much, and be sure and submit your survey results on this so that you can be up there on the leaderboard next week or tomorrow rather. Thank you very much.
Thank you.